Hello everyone, and welcome to our 11.7 lesson on volume of pyramids and cones. 11.7a was about the surface area of pyramids and cones, but now we're going to start looking at the volume. And so the first thing that we made a note of was to remember that volume is always going to be in units cubed. And we're looking at pyramids and cones now, which of course each only have one base. So you're going to name a pyramid by its base. So you could have a square pyramid, a triangular pyramid, you could have a hexagonal pyramid. But for a cone, we only call it a cone because the base is always a circle. So while the shape of the base can change in a pyramid, in a cone, it's always going to be a circle. And so we did a little discovery in class today. If you weren't there, let me know and I can send you a video that will kind of fill you in and show you the why of behind where this formula comes from. So it's very, very similar to what we did the other day. The volume is going to be equal to the base times the height again, just like it was for prisms and cylinders, but we are going to divide that by 3. So you can look, every single one of these has a vertex at the top, and you can tell that the volume as you go from the bottom of this shape to the top gets smaller and smaller and smaller. And so we're going to do base times height divided by 3, where B represents the base area. So it's not just some random number on the base, it's the area of whatever the shape the base is. And H is going to represent the height of the pyramid or the cone. And so notice that all of these we talked about, and somebody asked a really, really good question in my 4th period class. They said, Ms. Hall, why are we all of a sudden working with the capital H instead of the slant height? And so that's a brilliant question. It's because we are working with the volume of the shape, and volume works with the inside space, where surface area, like how much plastic it took or water it took to build a cone that holds those little water cups. When we look at that, we're looking at the outside. We're looking at the walls. Now we're looking at the space on the inside, so we're going to work with our height that's on the inside from the top of the shape to the base. So it says solve for the volume. For pyramids, we're going to round to the nearest tenth, and then whenever we get to the cones, we're going to leave them in terms of pi, since they have circular bases. That's just what my directions say to do, so that's what we're going to follow. And we did not do every single one of these problems in class. In fact, I assigned some of these to a few different groups. So we're going to jump around a decent bit. We're not going to do every single problem. I will upload the key to every single problem, and that way if you wanted to try a few on your own, you absolutely can. Okay, so we want to find how much volume is inside of this shape, and the first thing I had students do today is practice naming the shapes. And so this shape is going to be not a square pyramid, I almost said square, but because it's a 5 by 3, when I look at the base, that is not a square pyramid, that is going to be a rectangular pyramid. So you name it by its base, rectangular pyramid. And the formula for a rectangular pyramid is volume equals base times height divided by 3. And so when you do base, it's not a random number on the base, it's the area of this base. So how do you find the area of that rectangle? 5 times 3 is going to give me 15 inches squared of area. So that's going to give me 15. We're going to multiply that by the height, which is given. That's going to be the 4. And so it's going to be 15 times 4 divided by 3. And we talked about getting into the habit. Your calculator will do order of operations, but you need to make sure that you have typed it in correctly. What we did in class, just because we're going to end up having some radicals pop up, we're going to type in the numerator and click enter, and then divide by 3. You could absolutely do 15 times 4 divided by 3 and you'll get the same answer on this one. But there are certain situations where you have radicals that pop up and you have to remember to close the parentheses on certain calculators, which many students forget to do. So we know that 15 times 4 is 60. So part of the reason I like doing just the numerator is that shows me what the volume of the shape would be if it had a top base and if it was a prism. So if there was another rectangle like that right here and I connected these, the volume of that shape would be 60. But that's not the case. We've got to divide that by 3. So what is that going to give me? That is going to give me a volume of 20 inches cubed. So my total volume on the shape, inside of this shape, is 20 inches cubed of space. Okay. Now we did do the next problem in class. This one's a little bit harder. This is actually a square pyramid. You could still say rectangular, you would not be incorrect, but we can go even a little bit more specific. This is a square pyramid because it's going to be a 5 by 5. So we know that that is a square. Okay. And so when I find the volume of that, it's going to be base times height divided by 3. And so again, be careful. That's not a random number on the base. That is the area of the base. So what is the area of a 5 by 5 square? We know that that's going to give us 25. So I'm going to fill in 25 feet squared is my base area. Well, what is my height? Unfortunately, I do not have it here because the height is going to be going to the base. What I have is my slanted height that goes from here to here. That is the height of the wall. I don't love it being in that spot just because it makes it a little bit complicated when we're looking at our picture. So we know that if it's the height of that triangle and this is a square pyramid, that 9 is also going to be the height of this triangle. So I can just move it over here and scratch it out. We know that that 9 feet can just move over and scooch over. So I'm going to cross it out from here just so it doesn't confuse me. And then to find the distance from this height, the center of the square, to the where you measure for the 9 feet, you're going to take 5 and you're going to divide it by 2. So that's going to give me 2.5 for this piece of the right triangle. And so I'm just going to use Pythagorean theorem. H squared plus 2.5 squared equals the slant height squared. I don't need the slant height for volume. I need the height that is happening on the inside of the shape. And so a really easy way to type this into your calculator is just to do 9 squared minus 2.5 squared. That is going to give me, I typed it in wrong. 9 squared minus 2.5 squared is going to give me 74.75 for h squared. So if I want to know what h is, I'm going to take the square root of 74.75, and so that's what I'm going to copy right here. I don't want to round it more than once, so I'm going to wait until the very, very end. So I'm just going to leave that as the square root of 74.75. And then we're going to do that divided by 3. So again, when we type this in, what happens when you type in 25 square root, it immediately on some calculators pops up with an open parenthesis. And so when you type in 74.75, now if you have a graphing calculator, that won't be an issue, but you still have to remember to scroll to the right to get out of the radical symbol. You're going to go ahead and multiply those, so you get 216.145, and then you're going to divide by 3. If not, you'd have to remember to close your parentheses, which again, just many people forget to do that. So this is going to give me a volume of about 72.0 feet cubed, because it says to round to the nearest tenth. 72.0 feet cubed. Okay, so that's how much space fits inside of this pyramid. So that pyramid is obviously a little bit bigger, a decent bit bigger than our first pyramid. Okay, so there's 2 other ones like that have a slant height. So you'd have to find your height here. Again, you can copy it where you want to, or you can use this as the hypotenuse. And then here, you just have to put a 5 here. And so we'd use Pythagorean theorem to find our height. Same thing on this other problem, but because the slant height is in the front, if I were doing this problem, I would move the 22 to over here just because it makes it a little bit easier to look at, and then move the height to here. And that just helps us have a little bit more space. So half of 14 would be 7, and so then we'd be working to find h. Okay? We're going to skip those 2. If you need to come back and check the key for those later, you absolutely can, but that's very similar to what we've been doing. It's just that I've been giving you the slant height and you finding the height, or giving you the height and you finding the slant height. So the same concept. The slant height is always going to be your hypotenuse in that right triangle. Now we did want to do an example where you had to draw it out. So this was not a mistake that there's not a picture printed on this one. We wanted to make sure that y'all are able to visualize the formula if needed. So we know that for volume, it's equal to base times height divided by 3. And some people can jump straight to the formula from a given scenario. A square pyramid, so that's going to be important. They tell you that for a reason. Has side lengths of 24. If it's a square, it's going to be a 24 by 24, and it has a height of 10. So if you can jump straight to the formula, fabulous. But if you need help with a visual, we are not trying to win any awards here. We're not trying to be Picasso. This does not have to be perfect. I'm drawing a square pyramid, so I'm going to draw a square. It says it has a side length of 24 meters. I know that if it's a square, that's going to be both of those. And then it has a height of 10. I don't even draw in all the walls. I just come to a point. But I just go ahead and do that. I know that there are walls in the back. If you want to put those on there, you can. But it has a height, which is what I need. It says of 10 meters. So from the top point all the way to the bottom is going to be 10 meters. And so this just makes it really easy for me to calculate what I need. So when you do 24 by 24 for the area of this square base, I believe that gives me 576. And so you're going to multiply that by your height, which they tell us is 10. And then we're going to end up dividing that by 3. So 576 times 10, enter, divided by 3. That's going to give me 1,920 meters cubed for the volume of this specific square pyramid. So that's the biggest square pyramid I have done so far. Oh, hold on, y'all. These are not all in feet cubed. So I misspoke earlier. I'm so sorry. We have 20 inches cubed. Then we have 72 feet cubed, so obviously that's way bigger. And now we have 1920 meters cubed. So I've been changing the units up on y'all. So you can't necessarily just compare the numbers. You'd have to look at the units as well. All right, so let's keep going. We're going to skip these next three. Check the key if you want to see those later. Then we talked about cones, and so I held up a cylinder in class, and we talked about how the formula is still volume equals base times height divided by 3. But because it's always a circle, I get to fill in this formula a little bit more. I get to be a little bit more specific, because what is always going to be your area of a circle? Your area of a circle is always going to be pi r squared. In class, just to remember this in a silly way, we say fuzzy wuzzy was a bear. Area of a circle is pi r squared. So it's going to be pi r squared times your height divided by 3. So the only two variables you need to find the volume of a cone are the radius and the height. Now this is important. You cannot interchange those, because r is being squared and h is not. So the 3 has to be the height because it's not being squared. The 1 has to be the radius in this picture. And so just be careful on that. You cannot flip-flop the 3 and the 1, or that's going to totally change your answer. And so this will be pi 1 squared times your height of 3 divided by 3. So again, when we leave things in terms of pi, we're going to type in everything in the numerator except for the pi symbol, because we know that we're going to have that many pi centimeters cubed. And so I'm going to do 1 squared times 3. That's going to give me 3. And whenever you do 3 divided by 3, that's going to give me a total of 1 pi centimeters cubed. 1 pi centimeters cubed. Okay? So make sure all of these are to the 3rd power when you're working with volume. Okay? This next problem is a little bit harder because, again, I do have a radius on this problem, which is nice. So there's my radius. Oh gosh, that is not a, there's the highlighter, so there's the pen. So there's my radius. So when I go volume equals pi r squared h divided by 3, since it's a circle, I can fill in for my radius. That's going to be pi, let's do it in that same color so I'm consistent. Y'all know that bothers me. Pi 6 squared times my height. Well, do I have the height that I need? I do not. So I'm going to have to use a little bit of Pythagorean theorem on this. So I'm going to use h squared plus 6 squared equals 11 squared. Y'all have done such a good job just taking shortcuts with the Pythagorean theorem without having to show every step like you did in middle school. 11 squared minus 6 squared is inevitably what you're going to type in your calculator there. That's going to give me 85 for h squared. So what is h? H is going to be the square root of 85, which we know is going to be a decimal. So I'm just going to leave that as the square root of 85 and round at the very, very end. So I'm going to multiply that by root 85, and then I end up dividing by 3. So y'all have done a fabulous job on finding calculator shortcuts to make this quicker. So we want to leave it in terms of pi. So I'm going to type in 6 squared times root 85 to see what that coefficient would be. 6 squared times the square root of 85. Either close your parentheses or go ahead and click enter. So that's like 331.9. It keeps going. Then we divide that by 3. So how many pi's am I going to have approximately when I round? It's going to be about 110.6 pi feet cubed. If you wanted to change that to a decimal, or a fraction, if they ever did that on the ACT, it'd be a huge number, and the numerator would be 285,769 over 2583 pi. So if they ever had improper fractions on a standardized test, you'd easily be able to divide those or simplify those in your calculator and see what that would simplify to as a fraction. So that is the volume of this cone. So the next one we did, we kind of skipped around. We did a word problem, but we chose the harder word problem as a class. And so we're going to skip to that. We did talk about this problem. The way that they try to trick you is that they give you the diameter. So how do you find the radius? Well, we're going to fill in r equals 5 because you divide by 2. Y'all have done a great job of that. The only thing I see a lot of students do is they are they go to plug it in, and y'all, our eyes just naturally trust that thing that is in print over the thing that is written. So once you've used the diameter to find the radius, cross that out because you don't need that anymore, and don't accidentally plug that into the formula because your eye is naturally going to grab that 10 inches that was printed over the 5 inches that you wrote. So we did an example. It's kind of like that. We actually I had people use that as a calculator check just to make sure they knew how to type it in. And many people were able to jump straight to the answer for that. So that's fabulous. I do ask that on the test you show work so that I can give partial credit when possible. Okay, so this next question said a cone has a diameter of 10 and a height of 5. Again, if you don't need a picture, that's fabulous. If you can jump straight to this formula, I think that is great. I'm one of those people that likes having a visual, especially when it gets tricky and it says a diameter. It just helps me have a visual. So we know that a cone is made up of a circle, and it's got this little triangular shape coming out of it. And we have our height. It gives us our height. It says the height is 5. That's what I need for my formula. So this height is 5, so I just write that giant 5 centimeters. But then it gives me my diameter, which I know goes all the way across. We don't want to go all the way across. We want a radius. And so if my diameter is 10, I don't even put that in the picture because that's not what I need. I'll go ahead and draw it in the picture what I need, and I just find it. So we do 10 divided by 2, if that's my diameter, and that's going to give me a radius of 5 centimeters as well. So what's interesting is whenever you do pi r squared h, that's going to be pi 5 squared is my radius, so that's going to be 5 to the second power r squared times my height, which is also a 5, divided by 3. You could type this into your calculator, but 5 squared times 5 is going to be 5 cubed, which is 125. And then 125 divided by 3 is going to give me 41.6 repeating pi centimeters cubed. If you wanted to do this as an improper fraction, of course we know how to do that in our calculators now. That would be 125 over 3. So you could have left it as the improper fraction. So, or 125 over 3 pi centimeters cubed. Okay, so regardless of how they present it, you'd be able to convert if needed. Okay, and so that is where we kind of stopped in the notes. So again, I'll upload the answer key to the rest if you need more practice. But because y'all did such a good job and put in such hard work on the prisms and cylinders, this seems to be a little bit easy. Now, I do want to say this. We mixed in, I call them Easter eggs, we mixed in a few cylinders and prisms into your homework to make sure you know the difference and when to use each formula. So just pay attention to that. Not everything is base times height divided by 3 because we wanted y'all to practice differentiating between when you see a cylinder, that's just base times height, and when you see a prism, that's just base times height. The only time you divide by 3 is if it's a pyramid or a cone, and that's because it's the formula. So again, you will be given the formulas for surface area and volume on test day. So since we are not asking you to memorize those, we are going to supply you with the formulas. We're going to ask you to apply the information and know what each thing stands for. So application is going to be key in knowing what each thing stands for and how to calculate each variable. So I hope you're having a fabulous day, and then the homework is on the back, and we will check that tomorrow.